Hello everyone, welcome to Genius Tutorials. Today in this session we are going to discuss that how can we calculate total number of functions, total number of one functions, many functions, onto functions, into functions. In this session we are basically going to deal with all those type of questions in which we have to calculate the exact number of functions and different type of functions that can be formed between two sets, okay, from set A to set B. In past years, we have seen that many questions have been asked from this topic. So, if you are comfortable with all the concepts and definition of functions and onto functions, one functions, then you can easily manage all these type of questions. Okay. Let's start with today's session. But before that, do subscribe to our YouTube channel and give your valuable comments also if you have any suggestion for us. So you are always welcome. Okay, let's start with today's session. Basically, first of all, let us discuss the total number of functions that can be drawn from set A to set B. Suppose there is a set A. This is set A and this is set B. Okay, and set A contains say R elements, and set B contains, you can say, n elements. Okay, so according to definition of function, first thing is there are two conditions that must be satisfied for function. First of all, that every element of A, that means every element of domain must be defined. That means for every element of A there must be an image in B. And second condition is that every element of A can have only one image. Okay, no element from A can have two images. If one element have two images, that means that is not a function. So if this A has R elements and B has n element, that means now this element number 1, this can have how many images possible? This it can have any image. So basically, for total number of function, we can say that any element of A can get any number of objects in B. Okay, this is like simply that permutation question. So any element of A can get any number of objects in B. So that means this first element can have all possible images. So for first it can have n images possible, for second also n, for third also n, so on up to, then how many times this is? This is r times. So we can say that total number of functions will be n to the power r. So if in general we can say that total number of functions will be equal to order of B raised to the power order of A. That means if we define function from A to B, and if I say A has 5 elements and B has 6 elements, then how many functions can be drawn? 6 to the power 5. This much functions can be drawn from A to B. Okay, so this is how we can calculate the total number of functions that can be drawn from set A to B. And whenever we want to calculate total number of functions from A to B, it hardly matters whether the number of elements in A is greater than B or less than B. Functions can be drawn from A to B. Okay, it hardly matters whether A has greater number of elements in A is greater or number of elements in B is greater. But yes, it will matter in case of one function, onto function. But in case of function, it hardly matters whether number of elements in A or number of elements in B, which is greater. Okay, so you just remember, if A has R elements and B has n elements, then total number of functions will be n to the power r. Okay. Okay, let's move on to next point. Next is how can we calculate total number of one functions. Okay, so before going to discuss that, let us understand what is one function. Suppose this is set A and this is set B, and we want to draw one function. One function means, suppose this is A, this is element A, this is B, this is C, this is D, and this is 1, 2, 3. If I say that image of A is 1 and image of B is also 1, image of C is 2, and image of D is 3. Do you think this is a function if two elements have one image? Yes, this is a function. two elements can have one image. That is a function, but this is not a one-one function. One-one function means distinct elements must have distinct images. Okay. So distinct element, that means different elements must have different images, or mathematically we can say that if fx is equal to fy, that means if two images are equal, then we can say that x should be equal to y. Okay. If fx is equal to fy, then x should be equal to y, or you can say if fx is not equal to fy, then x is not equal to y. But in this case, f of a, this is equal to f of b, because f of a is also 1, f of b is also 1, but a is not equal to b, so we can say that this is not a one-one function. So one-one function is also called injective function. Okay, so if it is asked that how many injectivities are possible or how many injective functions are possible, that is one and the same thing. Total number of one-one functions are asked. So now we have to calculate how many injective functions or how many one-one functions can be drawn. Now suppose A has you say 7 elements and B has you can say okay, you take 5 elements. Okay. Now if I need to calculate how many one-one functions are possible from A to B. Now 1, 2, 3, 4, 5, 6 and 7, and here A, B, C, D and E. Now this 1 has A, 2 has B, 3 has C. Okay, if I draw these injections, these functions, these images, that 1 has image A, 2 has image B, 3 has C. So now two elements 6 and 7 are left in A. Okay, so but as I said that for a function every element should be defined, so no element in A should be left out. So what we can say, we can make 6 as image, any image 6 as image B or A, but that will satisfy definition of function only, that will not be a one-one function. Okay, so for one-one function the number of if number of elements in A is greater than number of elements in B, we can say the one-one functions are not possible. Okay, if I say that how many functions are possible in this, that is clear, 5 to the power 7 as we done in previous case. But number of one-one function is not possible if number of elements in A is greater than number of elements in B. So this is clear that no injective functions are possible, no injections are possible in this case if order of A is greater than order of B. Okay, so okay, now this is clear that order of A and B matter in case of one-one function. To find injections, we have to be very careful that what is the number of element in set A and set B. Now let us take second subcase, that if say number of elements in A is 5 and number of elements in B is 7. Okay, now we can say 1, 2, 3, 4, 5 and here A, B, C, D, E, F and G. Now we have to calculate the total number of one-one functions. Okay, so for one-one function we can say this 1 can have any image. It can be A, it can be B, it can be C, it can be D, any one image. Okay, and then 2 can have any other image, 3 can have. So what we have to calculate here, we have to select 5 elements from set B which are images of these 1, 2, 3, 4, 5. Okay, so basically we have to select 5 elements out of these seven entries and then arrange them. So 7c5 into 5 factorial, this will be the total number of one-one functions from A to B. Okay, or you can say 7p5, that is also one and the same thing. So if I generalize it, we can say that if A has m elements and B has n elements, then we have two cases. If m is greater than n, then 0 one-one functions are possible. M cannot be greater than n. And if m is less than or even if it is equal to n, then what we can do here, NCM into m factorial. Okay, so this will be the total number of one-one function. This is how we can calculate total number of functions and total number of one functions. Now, what are many one functions? Those functions which are not one function, they are many one functions. So this is quite simple. If we need to calculate many one functions, then that means, okay, if I take both these cases, let me take it on another page. Okay, now we want to calculate total number of many one functions. Again, if m is greater than n, what is m and n? If we want to draw a function from a to b, and m is number of elements in a and n is number of elements in b. If m is greater than n, then how many one functions are there? No one function is possible. Okay, that means all the functions are many one function, n to the power n. All functions are many one. Basically many one functions, जो functions one nahi hai, they are many one functions. Okay, so if m is greater than n, no one function is there. That means all n to the power m, all functions are many one functions. And in case if m is less than n, then total number of functions, that means n to the power m minus those ncm into m factorial. This will be the total number of many one functions. I hope this is clear. And in terms of permutation, if you want to write it down, then total number of one functions. What is total number of one functions? That will be that each element gets exactly one object. Okay, each element in A get exactly one object in B. Each element of A get exactly one object in B. Okay, and what will be many one function in terms of permutation? This is just writing. This is just a way of writing that statement. Many one functions means at least one gets more than one ball, okay, or more than one object. Okay, because if at least one gets, it can be maybe possible that 2 or 3 gets more than one, but at least one gets more than one. So this is how we can calculate total number of functions, many one functions and one functions. Now let us approach to this next case, that how can we calculate onto functions and into functions. So before going to discuss that, we have to understand what is onto function and what is into function. Basically, if I say that this is set A and this is set B, and a function is made from A to B, okay, so we have to check whether this function is onto or not. Okay, so basically if I say that suppose this is a set of natural number and this is also a set of natural number, and if I say that fx is equal to x here, this is a function. So we can say that image of 1 is 1 and image of 2 is 4, image of 3 is 9 and so on. Okay, so one thing is sure, that if I take image of any element of A, that will be defined in B, because we can find square of all natural number and that will also be a natural number. So square of any natural number is a natural number, so that means this is a function. But here are some elements in B. Suppose there is element 2. So 2 is square of root 2, but root 2 is not a natural number. No? Root 2 does not belong to set of natural number. So that means there are some elements in B which are not images of any element of A. Okay, so there are some elements in B whose pre-image is not there. So that means this function is not onto function. Onto function means for every element of B, there must exist x belongs to A such that fx is equal to, for any element of B you say y. Okay, there must exist x belongs to A such that fx is equal to y. That means every image must have its pre-image, or you can say every element of B must have its pre-image. Okay, जैसे मान लो मैथ्स की बुक है, उसके पीछे आंसर्स दिए हुए हैं, फॉर एवरी आंसर देयर इज अ क्वेश्चन. ओके, कोई ऐसा क्वेश्चन आंसर तो नहीं जिसके कॉरस्पॉन्डिंग कोई क्वेश्चन ही ना हो. So for every answer there is a question. That means that is an onto function. So onto function means every element of B must have a pre-image in A. Okay, and onto function is also called surjective function. Okay, so I hope this definition is clear. And what are into functions? जो function onto नहीं होंगे, they are into functions. So total number minus onto function, that will be an into function. One more thing which I want to mention here, that in case of onto function, range will be equal to codomain. That is very obvious. Okay, because there will be no element in B which is not image of any element of A. That means range is equal to codomain in case of onto function. Okay, so this is clear. And what is into function? If I say that range is a proper subset, if range is a proper subset of codomain, that means that is not an onto function, that will be an into function. So if range is equal to codomain, that will be an onto function, and if range is a proper subset of codomain, that will be an into function. Now this concept is clear, that what is an onto and what is into function. Now let us discuss how to calculate total number of onto functions. So what we can do here, just a minute. Okay, so what we can do here, we have to calculate total number of onto functions. So total number of onto functions, to calculate total number of onto function, we have to use inclusion exclusion principle. Okay, now let us take a first case. Suppose if I say that number of elements in A and B, suppose B contains A, B, C, D elements, and number of elements in A is 1, 2 and 3. Okay, so we can say image of 1 is A, image of 2 is B, image of 3 is C. So D is image of which element? No, we cannot say that D is image of 3 also, or you can say 2 also. Okay, because one element cannot have two images. That is not definition of function at all. So if number of elements in B is greater than number of elements in A, that means no onto function is possible in this case. I hope this is clear. Okay, so total number of onto function, before going to calculate total number of onto function, you must be very sure that number of elements in B cannot be greater than number of elements in A. Okay, because in that case all elements in B are not images of A, na? Okay, so this is first case, that number of elements in B cannot be greater than number of elements in A. So if number of elements in A is greater than number of elements in B, okay, you can say number of elements in A, say this has m elements and this is n element, and m is greater than n. Now how can we calculate? We have to use inclusion exclusion principle. And how can we do that? Total number of function is n to the power m, and we have to eliminate all into functions. And what are into functions? That will be nc1 into n minus 1 to the power m minus nc2 into n minus 2 to the power m plus nc3 into n minus 3 to the power m, so on. So basically these elements which are written in this bracket, these are into functions, and if I exclude all those elements, all into functions from a total number of functions, that will give us total number of onto functions. So this is how we can calculate total number of onto functions, total number of into functions. Okay, so I hope you enjoyed the session, and do subscribe to our channel if you have not subscribed it yet. And our PGDBA online crash course is going to start from 25th of December. So if any one of you want to enroll in that, you can just WhatsApp me at my WhatsApp number is 98965 8114, and all details are otherwise given in this description below. So we will come up with more such session. Thank you so much.